All right, so today we're going to look at 8.5, the third part of it. If you're following along in the packet, it is section 5.5. All right, so first thing I'm going to do is just start off by defining what the dot product is. Okay, we'll practice doing a couple just basic calculations with it, and then I'll show you what you use the dot product to actually do. Okay, it does something. All right, so suppose we had two vectors, okay, v and w, and I've written them in unit vector notation. Vector v has a horizontal component of a1 and a vertical component b1. And vector w has a horizontal component a2, vertical component b2. a1, b1, a2, and b2 are all numbers. Okay, so if we were doing an actual problem, those would all be numbers. So if you want to find the dot product between v and w, okay, written just like that, v dot w, and I'll explain in a minute why you have to say it the way I just did. All you have to do is take a1 and a2, multiply them together, take b1 and b2, multiply those together, and then add those two results up. Okay, and that's it. That's the dot product. All right, so now I just want to go through that and kind of look at it and make sure we understand what's what in that thing. What does v represent? V is a what in that equation? It's a vector. Okay, so I either should make it try to look a little more bold or put an arrow above it. And what is w? That's also a vector. So what I just showed you how to do is multiply a vector times a vector. Okay, we've never done that. We've multiplied a number, times a vector. Okay, something like that. That's just scaling a vector. That's a little different. This is multiplying a vector times a vector. Okay, and specifically, this is multiplying two vectors using what's called a dot product. Okay, there is another way to multiply vectors, okay, written like that. That's called a cross product. So with numbers, if I just said to you to multiply 2 times 3, there's only one way to do it. There's only one answer you can get. But if I said to you multiply vectors v and w, the next question you should ask me is, well, how? You need to be more specific. Do you want me to multiply the two vectors with a dot product? You want me to do it that way? Or do you want me to multiply the two vectors as a cross product? So there's two ways to do multiplication with vectors. This way doesn't exist in 2D. There's no such thing as a cross product with 2D. You can only do this one in 3D. Okay? But dot product we can do in 2D or 3D. Doesn't matter. All right, so I want to look at what kind of answer I'm going to get here. What is A1? If we were doing an actual problem, what kind of thing would that be?
Steak sauce.
A what?
Steak sauce.
Steak sauce.
Oh.
I got you. It was a little slow. All right. So it could be, yes, it could be the name of a steak sauce. Or, in this problem, A1, A2, B1, and B2 are all real numbers. Yeah, we're not doing imaginary. So if you take A1, which is a number, times A2, which is a number, what's a number times another number?
A number.
That's a number. And then B1 times B2, that's a number times another, that's another number. And then what do you get if you take a number plus another number?
A number.
A number. So,
What kind of question?
so what does that tell you the dot product is? What kind of, the answer is a number, yes.
Oh, thanks.
Well, some people, they get confused with that. So when you do the dot product, the answer that you get, okay, could be like 12, right? Just a number. The important thing to understand is when you do a dot product, the answer is not a vector. Okay? When you add vectors, you get a vector. When you subtract vectors, you get a vector. When you take a vector and make it longer or shorter, you get another vector that's longer and shorter. But when you multiply vectors the way I'm showing you right now, you don't get a vector. You get a number. When you multiply them using what's called a cross product, maybe we'll look at that tomorrow, that's a little different. You don't get a number. All right, so I want to find the dot product between v and w. And that's it. Just want to find that dot product. Okay? We're not going to do anything with that number for now. We'll just see if we can figure it out. Okay, and the first way I want to do it is v dot w. Okay, I want to do it in that order, v dot w. Okay, so if I want to find v dot w, what would be the first two numbers I multiply together? And I would do them in that order. Yep, 2 and 5. And what comes after the 2 times 5? Plus. And then I would multiply negative 3 and 3. So it's going to give me 10. And then plus negative 9 is really just minus 9. So what's the dot product? 1. Okay, so the dot product of v and w in this case happens to be 1. Now let's switch it and let's write it as w dot v. Okay, and see what happens here. How would I write the calculation if I want to do it in that order? W dot v.
Negative 3 times 3 plus 2 times 5.
Not if we're going to follow that formula. It wouldn't quite be like that.
5 times 2.
It would be 5 times 2. Okay, so now the w's, think of that as your a1 and b1. Okay, that comes first. So 5 times 2. And what would come next? 3 times negative 3. Okay, so following the formula I just had, that's exactly what w dot v would look like. And what do you get? You get the same thing. So what does that mean about the dot product?
It's always the same.
Okay, when you switch the order, it's the same, but what's the word for that?
Symmetric.
Not symmetric. That's a good guess, because that is a property we do use a lot, and that does involve switching things, but this one's a little different. Commutative. Okay, so this doesn't prove it, but it implies that the dot product is commutative, and it is. So when you do a dot product, you can switch the order, and you'll get the same answer. If we get to look at cross product, that's not true. And that might be one of the first times you've ever done multiplication where if you switch the order, you get a different answer. Okay? With a cross product, switching the order gives you a different answer. But again, we don't have to worry about that today. All right, let's find v dot v. V dot v. What would be the calculation I would do for v dot v? What times what plus what times what?
2 times 2 plus negative 3 times negative 3, right?
Yeah, 2 times 2.
So it'd be 2 squared.
Yep, plus negative 3 times negative 3. Or if you just want to shorten that, it's really just 2 squared plus negative 3 squared. Now, before I finish that up, where do you see a calculation that looks like this sometimes when we're doing what? When you're finding the magnitude, right? You square something else, and you add them up. There's one thing missing from this that the magnitude would have that this doesn't. It's missing the square root. Okay? So now I'll finish the calculation, and I'm going to tie in what I just said with the answer I'm about to get. So 2 squared is 4. What's negative 3 squared? 9. And that gives me 13. So the v dot v is 13. So what would be the length of v? It would be the square root of that. That's the only thing we didn't do. We didn't take the square root. So let's try that again with w dot w. And let's see if we get the length without the square root. Okay, we'll see if that happens again. All right, so what would be the calculation for w dot w?
5 squared plus 3 squared.
Yeah, it's almost like you're finding the magnitude, except you don't take the square root. 5 squared plus 3 squared. So 5 squared plus 3 squared, and the dot product would be 34. So, from those last two examples, if you take a vector and do the dot product with itself, okay, if you do this, you don't get the magnitude of the vector, but you get the magnitude squared. That's what you get. If you dot a vector with itself, you're missing the square root. So 34 is actually the square of the magnitude. The actual magnitude, I'd have to put in the square root. That's exactly what I just wrote. Okay, any questions on that? All right, so could I do, this is like a yes or no. Could I do 4 dot v? Is that something I could do?
No.
No. That's impossible. That doesn't make sense.
You need two coordinates, right? Or
Two
vectors.
vectors. Right, whenever you want to do a dot product, the two things that you're using have to both be vectors. You can't do the dot product of a number and a vector. That doesn't make sense. Okay. All right, so here's another one. This time I didn't write it in IJ notation. Okay, what am I going to get when I find the dot product between those two vectors? 0. Good. 2 times 0 plus 6 times 0. And that gives me 0. Is that 0 the number? Or is that 0, and I should have an arrow on top of it, the vector?
0.
0 the number, right? Because when you do a dot product, the answer is always a number, not a vector. If you did something like this, that you can do. That's a scalar product. It's basically saying to take the vector and scale it by 0. Right? Or you could scale it by 2 or 1/2 or whatever number you want. What would be the answer to that problem if you scale a vector by 0? Yeah?
0 vector?
The 0 vector. Yep. So that's something that's kind of important to understand the difference between 0 the number, 0 the vector. Any questions on the difference? Okay. So we're not going to go through the proof, but basically the dot product is distributive. Okay, we can't assume that it was distributive just because other things are distributive, but it is. The distributive property works fine with the dot product. Okay, and what we can really use the dot product for is to find the angle between two vectors. Now, let me, I'm going to put in a page for a second because I just want to show you something. Let's take two vectors like 2i plus 3j, and let's take 4i minus 5j. Okay, I'm going to draw those two vectors. Okay, and you know what? I should really do this with axes. That'll just make it a little easier. Okay. And what quadrant would 2i plus 3j be in? Yeah, first quadrant. And if I start from the origin, what's the name of the vector called? Position vector. So I'm going to go right 2, and then up 3. There's that one. And what quadrant would 4i minus 5j be in? Be in quadrant 4. So I go right 4, and then down 5. And there's that one. So the goal here is to find the angle between the two vectors. Technically, there's two angles. There's this one, and then there's the one on the outside. We're always going to be finding the one on the inside, okay, the one that's smaller than 180. All right. If I didn't teach you any kind of formula, what do you think you could do with that to find the angle yourself? Because you should be able to figure out this angle right now. Yeah?
So the top angle, is that a 45-degree angle?
No. No. I mean, this angle is probably a pretty messy answer, so I'm not asking you exactly what it would be. But what do you think you could do to this diagram to start to figure it out? Okay, trig, yes.
You can draw right triangles with the coordinates, right? So you can go from 2, 3, and then draw a line down and then to the origin, and you already have those two side-to-side views.
Oh, okay, I see what you're saying. Yep, I wasn't even thinking of doing it that way. So you could draw that, make a right triangle, and then this side is 2, this side is 3, and you could find that. Right? So you could find that part, and then what would you do?
And then you can find the other angle by doing the same thing.
Yeah, and you could do the same thing again. Make a triangle. This side is 4, that side's 5, and then you could find that angle right there. I'm not saying they're the same, and then you would add them up. Yep, so that would work. That would work perfect. So you could figure out the angle with what you know right now. Okay, you've got enough information. Anybody think of a different way I could do it besides that way, where I don't have to add two separate angles together? What do you think what could I do first in this picture to make this more like a shape that we work with a lot? Yeah?
Triangle.
Yeah, I can make a triangle out of it. Let's pretend that these aren't vectors. Okay? It doesn't matter really that they are. Let's just pretend that they're line segments. Okay? What you could do is draw in that third side, and now you've got a triangle. Could you find the length of this side? Sure, you've got coordinates. You could use the distance formula or do what Luke did, make a right triangle, use Pythagorean theorem, but you could find the length of A. How about this side? Sure, you could find that one because you know the two coordinates. Use your distance formula again and use it again for the third side. So you could find the lengths of all those sides. And if you did that, what kind of triangle did we call that when we studied the two different laws? That would be a side-side-side triangle. Side, side, side. Does anybody remember what law you could use? You could use the law of cosines one time to find that one angle right there. Right? So you already know a couple different ways you could find that angle without me showing you how we're going to do it in this section. Okay, I'm going to give you a shortcut that avoids having to do the law of cosines. Actually, the shortcut comes from the law of cosines. Okay, if we were going to prove the shortcut I'm about to show you, we would use the law of cosines to prove it. Okay, but the shortcut's going to save us from having to do all that work. And you can probably guess by seeing the cosine in the formula, that's why it comes from the law of cosines. So the formula to find the angle between two vectors without going through all the work and using the shortcut is to find the dot product of the two vectors divided by the product of the magnitudes. So you need three things. The dot product, the length of u, and the length of v. Okay, you fill them into this formula, and then you'll have the cosine of your angle. Our last step is going to be to get rid of cosine. So we just have the angle. How would you get rid of cosine? Inverse cosine. Okay, so whenever you want to find the angle between two vectors using this formula, that's the last step. Use inverse cosine. Okay, so here I'm just kind of writing out what the formula says. The denominator is the length of u times the length of v. Or you could say magnitude. All right, so I've got two vectors, 4i minus 3j, 2i plus 5j. And I want to find the angle between them. Okay, so let's start by finding the dot product, because that's going to be my numerator. And then we'll find the length of u and the length of v. All right, so John, what's going to be the first two things I multiply when I do the dot product?
4 times 2.
Yep, 4 times 2. And other John, what's going to be the next two things I multiply?
3 times 5.
Careful.
Negative 3 times 5.
Negative 3 times 5, which is how much?
Negative 15.
Negative 15. Okay, so our dot product is negative 7. Okay, that's the first thing we need. Any questions on the dot product? Okay, now I need the length of each vector. The length of u and the length of v. Okay, so let's start with the length of u. Ian, can you tell me the calculation to find the length of u?
Yeah, square root of 4 squared plus 3 squared.
Square root, can you just say it one more time?
4 squared plus 3 squared.
Yep, perfect. And this is one I hope you recognize. It's going to come out nice. What's the length of u? Yep.
5.
5. Now, if you got something that was a square root you can reduce, don't worry about it. Because this number that I just circled is not a final answer. It's just a number that I'm going to plug into a formula to get a final answer that I'm just going to round off to a decimal. So you do not have to worry about reducing square roots. Unless you like to. All right, and then the length of v. Nick, what's going to be my calculation to do magnitude of v?
It's going to be 2 squared
Yep.
plus 5 squared, or after the square root times?
Yes, 2 squared plus 5 squared. And we're going to put all that in the square root. It's going to give me 25 plus 4. It's the square root of 29. I can't reduce it anyway, but I wouldn't worry if I could. Okay, now the three things I circled, plug them into that formula and solve it. And then you will know the angle. Okay, so cosine of our angle equals, what goes on the top?
So, negative 7.
The dot product, yep. And what goes on the bottom?
5 times
5 square root 29. Okay, and the last step I already asked you about earlier, that's the inverse cosine. So take the inverse cosine of what's on the left, just kind of squeeze it in on the right, type that in, and that's your answer. Okay, we can do it in radians or degrees. I'm gonna do this one in degrees since that's the mode my calculator's already in. So second inverse cosine, negative 7 divided by, and I'm going to put it in parentheses. I'm not sure if you need them, but I just want to make sure it does the order of operations correctly. You could try it on your own calculator without it and see if you get the same thing I do. Okay. So the angle between those two vectors, if you were to draw it out, is 105.07 degrees. And that's it. That's the angle between them. Now, that's really nothing special about that angle. Okay, 105.07, it's not really anything special. Does anybody know what a special angle would be if it came up? Or have a guess? Yeah?
Be like a 90-degree angle.
90 is a special one. Yep, we're going to talk about that. And what else? 180 is a special one. Okay, so 90 would look something like this. Two vectors. 180 would look something like that. And there's one more. 270 would be kind of the same as 90, but 360, which is the same as 0. So that would be two vectors that kind of look like that. One of them could be longer or shorter than the other, but they both point exactly the same way. When you have two line segments that make a 90, what do you call that?
Right angle.
A right angle? Yep, what else?
Oh, they're perpendicular.
They're perpendicular. So we'll talk about vectors that are perpendicular, and then these are vectors that are parallel, both of these cases. Okay? Parallel means they can point in opposite directions or same direction. So when we talk about vectors, the idea is still perpendicular. They just use a different word to describe it. They call it orthogonal. Right? So if you see a question that says, are the two vectors orthogonal? It just means, are they perpendicular? Okay, same thing. What did we just say the angle has to be if they're perpendicular? 90. So I want to work backwards with the formula and show you a shortcut to figuring out if two vectors are orthogonal. Okay, the angle would have to be 90. That would be on the left side of the formula. On the right side, you would have the dot product in the top and the product of the magnitudes in the bottom. You're going to see in a second, it doesn't really matter what's on the right-hand side, because watch what happens on the left. What's the cosine of 90? 0. It's 0. Okay, so if you got an angle that was 90, somehow this fraction would have to equal 0. What's the only way that a fraction can ever come out to 0?
0 on the bottom, right?
No, if you have 0 on the bottom, that's undefined.
Oh, 0 on the top.
If you have 0 on the top, the only way a fraction can ever come out to 0 is if you have a 0 on the top. And remind me again, what's in the top of the formula right here? The dot product. So the shortcut to figuring out if two vectors are perpendicular, all that has to happen is the dot product is 0. Because if the dot product is 0, then 0 divided by anything would come out to 0. And if you take the inverse cosine of 0, you get 90. Okay, so if you have a yes or no type question, are the following vectors perpendicular or orthogonal? Just find the dot product. If it's 0, they are. If it's not, then they're not. Okay, so this one, it says, are the vectors, that's the symbol for perpendicular, if you didn't know that, the upside down capital T. Okay, let's find our dot product. This time there's no number in front of I or J. So what number is always there if they don't put it? 1. So what's the dot product here? 4. It's 2 times 1 plus 1 times 2. That's 2 plus 2, or 4. So that's not the answer, but it does help us answer the question. Are these vectors orthogonal? No. Can somebody tell me one thing you could change that would make V and W orthogonal? You could change one thing. And you could actually do it in different spots, but you just have to change one thing.
All I have to do is change one of the, like, either the I and J in V or the I and J in W to 0.
Negative.
We can't, let's see, if you made it a 0, Luke, like this part, if you made it a 0, then it would be 2 times 0 would be 0, plus 1 times 2 would be 2.
Oh, yeah, I'm sorry. Negative.
Yeah, if you make anything a negative there, anything, it doesn't matter, then you would end up with them being perpendicular. Okay, any questions on that one? Okay, so we don't know what the angle is, but all I can say, I can answer the question. No, they're not perpendicular. Okay, if two vectors are parallel, okay, you guys mentioned this earlier, then the angle between them is 0 or 180. This would be considered parallel, two vectors that point in the same direction, and two vectors that point in opposite directions. It's both of examples of parallel. Now let's do the same thing we kind of did before. Let's work backwards from the formula and see if we can get a shortcut, like we did for orthogonal. Okay, let's start with 0. So if these vectors were parallel, you could have cosine 0 equals, and you'd have something on the other side. What's the cosine of 0? No, 1. Yep, the cosine of 0 is 1. So, how can a fraction come out to 1? There's only one way that can make it happen.
They equal the same with the top and the bottom?
Yeah, the top and the bottom come out the same. So it's not as nice of a shortcut as the last problem because you still have to figure out the top and you have to figure out the bottom. But if they come out the same, you'll get 1. And if you get 1, it means the angle is 0. Okay, let's look at 180. That's the other case where you could get parallel. Okay, what's the cosine of 180? It's -1. And what's the only way that a fraction would ever equal -1?
One of the either the numerator and denominator is a negative.
So just any negative number in the top and then any positive number in the bottom?
Same negative number.
Yeah, they're opposites. Okay, the top and the bottom have to be opposites. That's the only way you can ever divide two things and get -1. So those are opposites. Like 10, -10. So again, it's still not as nice of a shortcut as the dot product because we have to figure out the top and we still have to figure out the bottom. Okay, so that's as nice of a shortcut as you can get. Top and bottom come out the same, parallel. Top and bottom come out opposites, parallel. Okay, so I want to determine if those two vectors are parallel. Okay, what's the first thing I need to find to figure out if those are going to be parallel? Well, Curtis, what would be the first thing I have to find?
I'm not sure exactly.
Not sure. Bria? Yeah, I mean the dot product. Okay, when we went through this, you have to find everything. So you have to find the dot product, and then you have to find the magnitudes. So I'll start with the dot product, which is going to be 4 times 20 is 80. And what's -5 times -25? 125. And then we add those up. And what do we get? 205. Okay, so that's our dot product. Now I need the magnitude of V. Connor, what's going to be my setup here to find the magnitude of V? Yep, 4 squared.
Minus 5 squared?
When you do Pythagorean theorem, do we use a minus?
No.
Nope, it's always a plus.
5 squared.
4 squared plus 5 squared,
Square root.
and then take the square root of that. Okay, so that's going to give me 16 plus 25. What is the square root of 16 plus 25? Square root of 41. Okay, so we get the length of V. And now the last thing I need is length of W. Okay, Sam, what is 20 squared?
20 squared?
Yeah. Just think of it as 2 squared. But you have to add 2 zeros because it's 20. Alex? Yeah, 400. So 20 squared and 2 squared, it's the same thing. Except with 20 squared, you're going to add 2 zeros to the answer. So 2 squared is 4, add 2 zeros. 400. Hey, 25 squared. Anybody know that one? Yep, 625. Add those up. And I get the square root of 1,025. So I don't need inverse cosine. All I have to do is check what is the square root of 41 times the square root of 1,025. And if these vectors are going to come out parallel, what am I hoping that product comes out to? The same as what? The same as the dot product. So if I get 205 when I multiply these together, this times that, then they're parallel. Okay, well, let's check. So I've got the square root of 41 times square root of 1,025. 205. Right. So the top is 205 in the fraction. The bottom is 205. They just came out the same. They would be equal to 1, which means the angle would be 0. Right? You can go through if you want and divide the two things that are the same and you'll get 1. And then you can take the inverse cosine of 1, but you're just going to get 0. That's your final answer. So, determine if they are parallel. Yes. These are parallel. Okay. Any questions on that? All right, so last problem we'll look at for today. It's going to be a word problem. And let's see. So the word problem has to do with an airplane. And I think mentions two different speeds in the problem. There's airspeed and there's ground speed. Do people understand the difference between what those two things are in a plane? The airspeed of the plane versus the ground speed?
No.
Anyone think they could explain it? Yeah?
Isn't it how fast the plane's moving relative to the ground, right?
That's the ground speed.
And then how fast the air is moving relative to the airplane is moving relative to the air around it, like
Yes.
the wind.
Yep, exactly. So ground speed is basically if somebody was on the ground, pointed a radar gun at the plane, and the radar gun told you how fast it was going. That's the ground speed. The airspeed is basically if you stuck your hand out the window, how fast would the wind be hitting your hand? And those two things can be different. Okay? Because think about like if you were driving on the highway in no wind at all. There's no wind, 0 mile per hour wind, and you go 50, and you put your hand out the window. How fast is the air hitting your hand? 50. Yeah. But now let's say you're driving into a wind that's coming at you at 20 miles an hour. Okay? So you look at your car speedometer, it says 50. But you put your hand out the window, and the air is hitting your hand at 70. That's the airspeed. Okay, so there's a difference between airspeed and ground speed.
Well, what planes also like to do is when they're, a lot of times they're flying, they fly with the wind, so you can stick your hand out and the wind speed would be less than what it actually is if
So when you're flying, the two kinds of problems we can look at is, are you flying with the wind, so you're getting a tailwind and it's pushing you, or is it a headwind and that means you're fighting it? Okay, so in this particular problem, it says if you just want to write down airspeed equals 500, that's all you need to know from that, and the direction of the plane. The plane is going south. Okay, it's flying and there's a jet stream of 80 miles an hour, and the jet stream is blowing northeast. Okay, exactly northeast. I could pick a random direction, but if I pick exactly between north and east, it makes the angle relatively easy to figure out. I want to find the actual speed of the airplane, taking into account the jet stream, and the direction, okay, relative to the ground. So overall here, is the jet stream going to help the plane, or is it going to slow the plane down? It's going to slow it down. The plane isn't flying directly into it, but the jet stream is blowing north and east. The plane is trying to go south. So the jet stream's not helping it. It's going to slow the plane down a little bit. Okay, so even though the airspeed might say 500 miles an hour, the pilot's really not going to be going that fast. They would have to go faster than that to compensate for the jet stream. Right? So let's see if we can figure this out. The first thing you really want to do with all of this is make a picture. Okay? There's going to be two things I'm going to start with in my picture. I'm going to start with the 500 miles per hour, and what direction is the plane traveling in? South, which on the grid would be down. Okay, so here, I'm going to start, and I'll make it a different color so you can see it. That's the velocity vector for the plane. I don't know if you can really see that better. Let's just make it, red usually stands out pretty well. And we'll make it a little thicker. Okay, so there's the velocity vector for the plane. So I'm going to call that V sub p, velocity vector for the plane. Okay, and now I'm going to put in the jet stream. Okay, the jet stream is blowing northeast. Okay, if you're looking at it, this is east, that's north, west, and south. Okay, so I'm going to put the jet stream, but the jet stream is not as fast as the plane. It's only 80 miles an hour, so I'm going to draw it a little shorter. It doesn't have to be to scale, just roughly like that. Okay, that's the jet stream. Okay, any questions on that? Okay, and let's call that V sub w. Okay, that's the velocity vector for the wind. All right, so if the pilot didn't make any kind of correction, what would actually happen is the plane, I'm going to just add these two vectors together, just like we learned on the very first day of vectors. This is how the plane would travel. I'm going to put that back where it was. That black line represents the actual direction. The plane would be blown off course a little bit, okay, to the east, and it would slow down a little bit. Notice the arrow got a little shorter than it was before. And that would be the V sub a. We could call that the actual velocity vector, taking into account the plane and the wind. Okay? So the actual velocity vector is exactly what I just said. It's the velocity vector for the plane combined with the wind. How do the two affect each other? That's what we want to find out. What does it say? Find the actual speed and direction. So find the length of that black line and its direction. Okay, I want both of those. So the first thing I need to figure out is this and that. I need to write the information they gave me in the problem as velocity vectors. That's the cosine sine stuff. All right, so let's start out with the the velocity vector for the plane. All right. First thing you need is the magnitude. What's the speed of what's the airspeed of the plane? 500. 500. What trig function comes first? Cosine. And now I need my angle. So what's the angle if you're going south? Not the angle that would be on a compass, the angle the way we do it, if you go down. That's 270. Yep. And that's I, don't forget the I. Plus, what's the other trig function we use? Sine 270. And what letter do we put with that? J. Okay. Do that out, and that's the velocity vector for the plane. Okay. Let's do cosine 270 is 0. What's 0 times 500? 0. So I get 0i plus, now I'll do sine 270 is -1. And what do I multiply that by? 500. So it's really minus 500j. So you don't even need the 0. It's just negative 500j. Why is there no I component in the velocity vector for the plane? Because what? Why not? Why doesn't this have an I component?
Not beyond the x-axis.
Luke?
Because since traveling due south, it's right on the southern axis, or like the y-axis, so it
Yeah.
doesn't have any I.
Yeah, there's no left or right part to that v sub p at all. It's exactly up or down, in this case down. So if something is perfectly straight up and down, it doesn't have any left and right component to it. That's why there's no I. Now the jet stream will. The jet stream has a north component and an east component. But we have to see if we can also figure out the angle. Okay, so now the velocity vector for the wind. How fast is the wind blowing? 80. Cosine. Now I need my angle. Now, the wind is blowing exactly north and east. So it's making a perfect 45-degree angle. Okay, I wouldn't give you a problem other than the wind blowing north, east, south, or west, or exactly in between the four things I just said. I could say the wind is blowing at a 40-degree angle, but it's always going to be what I just said, either north, south, east, or west, or exactly between them. Okay, so cosine 45 plus, and what comes next? Oops. Nick, what comes next?
You gotta put sine
Sine of,
500j.
so what's our angle we're working with for the jet stream?
270.
Not 270. That's the angle for the plane. The jet stream is 45. And put our j. Okay. So now figure out that, and then we'll know the velocity vector for the jet stream. So 80 cosine 45 is 56.57 I. So the jet stream is blowing the plane 56 miles per hour east, and it's also blowing the plane a certain amount north. Okay, that's 80 sine 45. It's blowing the plane 56.7 miles per hour north. How come the amount it's blowing the plane east and the amount it's blowing north are exactly the same? Would that always happen, or why does that happen in this case?
Because it's going exactly north and east in the same amount.
Yeah, the wind is blowing exactly between north and east. So the amount north and the amount east is exactly the same. Right, so now we've got our velocity vector for the plane. We've got our velocity vector for the jet stream. Now, do that. Combine the two together, just add them up, and that'll give you the actual velocity vector that the plane is going to go, taking into account being blown off course and slowed down a little bit. Okay, so the actual velocity vector is when you combine the plane and the wind. Okay, let's start with the plane. The I component. Is there any I component for the plane? No. So when you combine that with the I component for the wind, it's 0 plus 56.57 I. Okay, plus, is there a J component for the plane? Yep, negative 500. Is there a J component for the wind? Yep, we need to add those together. Negative 500 plus 56.57. So negative 443.43. It's actually negative. That is the velocity vector for the plane. Now, I wanted to know two things about that. I'm just going to find one of them. I wanted to know the angle, which, now that you know this vector, you could take and do a dot product and find the magnitudes and use the formula I showed you. You could find the angle between the two vectors. Okay. But I just want to find the speed of the plane. Okay. Looking at the arrows, what is the speed represented by? It's the, what about the arrow? It's the length of the arrow. Okay. It's the magnitude. So I want to find the length of that arrow, and that'll at least answer that part of the question, okay, which is the only part that I'm going to do. So here's your vector. Find the length of it. How would I find the length of V sub A? That would be the first thing I do. Oh, John?
You gotta, wait, can you scroll up a little bit?
That's all you need to see.
There's a line.
And there's no formula that scrolling up would help you. It's the formula we learned yesterday. I mean, the numbers are a little bigger, but it's still the same. It's the same calculation to find the length.
So then you're gonna take 56.57 and squared.
Yep.
And then you're gonna add that to 443.43 squared.
Yep.
And then you're gonna take the square root of it all.
Take the square root. So let's just type that in. I'm just going to type it in all in one step and see how fast the plane is going. So 56.57 squared plus, it doesn't matter if I put the negative in because it's going to cancel out anyway. 443.43 squared. And do we expect the plane to be going faster than 500 or slower? Slower, because the jet stream is not helping it. So the plane is actually, in terms of the ground, it's only going to be going 447 miles an hour. Even though the pilot thinks he's going 500, that's because the wind is fighting him. Okay, so 447, that's close enough. That's the speed if somebody had a radar gun on the ground and could radar the plane. That's what the radar gun would say. Okay, any questions on that one? Okay, it's not too hard of a problem. It does take a little bit of time because you have to write down each vector with i's and j's. Then you got to add them up. Then you got to do the Pythagorean theorem to find the speed. So it does take a little bit of time. Great, but that's the only application we're going to look at for the dot product section. Okay, so the homework, again, tonight will be in the packet. On questions 7 through 17, each question has 3 parts. I think it says find the length of the vector, find the dot product of the vectors, and then determine if the vectors are parallel, perpendicular, or neither. So you really have to do the first 2 parts to do the third part anyway. They're all related. Okay. And also try question 25. Okay, I think that's an airplane kind of question.